Quantum mechanical orbitals. Okay, so we specify orbitals with a number and a letter. And the number is called the principal quantum number. And those are the numbers 1, 2, 3, 4, etc. And that specifies the principal shell of the orbital. So there's a little bit of overlap with the Bohr model. Level 1 is smaller and lower in energy. Level 2 is larger and higher in energy. And then as you go up, these orbitals, these regions of probability, get larger and higher in energy. The letter indicates the subshell. So we've got like a sub-level. So you've got the one level and then you've got sub-levels. And those are specified with letters. The 1, 2, 3, that's awesome. Right? Here are the letters, not A, B, C, D. S, P, D, and F. Isn't that nice? Those actually have some historical meaning. Every time I lecture on this, I say, I really need to look up that S. What does that mean? Because I can't remember. P stood for principal, D was diffuse, and F was fine. And it had to do with the characteristics of the lines in the spectra. So there's a historical meaning behind those letters. So let's look at the smallest, lowest energy orbital. So this is a dot representation. So this would be like that diagram I made of Andrew in the house, or like the one with the electron being pitched. So where's the electron at this time? Well, there it is. And where's the electron now? It's over here. And so you can get a map of where the electron is. And we see a pattern here that there's this region where we're probably going to find the electron, but it could be over here. So the dot representation, imagine taking a photograph of an electron every second for 10 minutes. It's more dense in here, and that represents a higher probability of finding an electron. Orbitals are three-dimensional. They're not like the orbit that the Earth does around the sun. So it's a volume, a spherical volume. Sometimes we represent them. Should not have eaten those frogs for breakfast. A geometric shape. So an s orbital is a sphere. So S for sphere, that's nice. This is not a container that the electron is found in. This is our representation of the region in which the electron is found 90% of the time. 10% of the time, the electron is not in this area. Okay? If we superimpose the dot representation and the geometric, we see that there's some dots that are outside that solid sphere, because the electron is not always inside that area. So when we have a hydrogen atom, how many electrons does a hydrogen atom have? 1. That one electron is going to be in the 1s orbital when it's undisturbed at room temperature. It's going to go to the lowest energy place that it can go, because electrons are like teenage boys. What's the normal state for a teenage boy? Asleep. Horizontal. If they're not actually asleep, they're in bed going like this, right? Doing something on their phone or their iPad or watching TV. They like to be horizontal. I know some of you guys are teenage boys. Young men, because you're not in high school anymore. I have several of these critters associated with me. They occasionally get up and do very energetic things. They go to football practice. They knock themselves out, expend all this energy. They come home, ground state, right? The 1s orbital is like the ground state. It's the lowest energy, and that's where the electron likes to be. Sometimes it absorbs energy and goes to higher states, but it can't maintain that, and it comes back down. That's the ground state, the lowest energy state Electrons seek that out. Input of energy, you zap it with some electricity. It gets excited, it goes to a higher level, but it can't stay there, and so it will come back down. So it can go to an excited state, but it's unstable, and then it'll go back to the ground state. All atoms have one ground state and multiple excited states, because you could excite that one electron to the second level, or the third, or the fourth, or the fifth, and when you get more than one electron, you've got all kinds of possibilities. So we said we represent the position of the electrons using a number and a letter. N is the principal quantum number. It's the shell or principal energy level. So the principal shell contains one subshell, this spherical orbital. The second principal shell has two sublevels, a 2s orbital, which is also a sphere but bigger, and then it has a p orbital, a p subshell. The p subshell has 3 orbitals in it. So there's a dot representation and the solid. Dot, solid, dot, solid. So there's 3 of them. They're kind of dumbbell shaped. They remind me of balloons. You know, here's the ends of the balloons, and they stick out from each other. And they're going to be arranged one along the x-axis, one along the y-axis, and one along the z-axis. They're going to be perpendicular to each other. They don't overlap at all. Yeah, I hear zippers. So we'll stop right there in the middle of section 6, because we're about to get into some different stuff.